This time we're drawing a rational function which is a little more complicated. You notice there's factors on top compared to the last video. So I'm going to start with the factors on top. Those are where my x-intercepts come from. These guys right here. Now the 24 is not important. I don't care about that at all. What I'm looking at is this parentheses right here. See this parentheses? X plus 1. If you solve that thing, you find that this is an x-intercept at -1. That's the x value if you set it equal to 0. And of course the y value is 0 because it's an x-intercept. So that's the first feature I can see in this graph pretty easily. The next one I want to move on to is the other type of asymptote. That's the the other type of intercept is a y-intercept. And those come from setting x equal to 0. So if you go ahead and set x equal to 0, you find where the function hits the y-axis. That's called the y-intercept. Now look what happens if I do that. It's easy to see in the unfactored form on the right. This thing goes to 0, this goes to 0, this goes to 0. It's like you're just covering them all up. And all that's left is what you have. So I've got my x value equal to 0, and then I have 24 over -6, okay? Which you can, I suppose you could write as 24 over -6 if you want, but that looks goofy. So let's just call this what it is. It's -4. So there I've got my y-intercept at 0, -4. The vertical asymptotes are a feature that you have in almost every rational function. You might have a rational function without them, but it's unusual. Those come from the factors on the bottom, which are not also represented on the top. And what I mean by that is there's no x minus 2 on the top. There's no x plus 3 on the top. So we just have two vertical asymptotes, and they're located at x equals 2 and x equals -3. Now the end behavior, or the end behavior asymptote, comes from looking at the weight of the function. So I'm going to clear some space over here. Come back over to the right side with the unfactored form. See, it is easy to see in this case. You've got a power of x squared on the bottom, and the greatest factor on top you have is x. So that means bottom heavy, right? In other words, bigger factors on bottom. And what that means is you have a horizontal asymptote located at y equals 0. There's no math required. It's always y equals 0 if it's bottom heavy. Now, if it's not bottom heavy, we'll deal with that in other videos. But let's go ahead and draw this function using all these features first to guide the approach. I'm going to do my asymptotes in red. So I have my horizontal asymptote right here. That's the end behavior of the function. That's y equals 0. And then I have two vertical asymptotes located at, let's see if I can do this, y equals 2. That looks pretty good. And then y equals -3, somewhere over here. Okay, so there's my two asymptotes. My two verticals, anyway. And I have a y-intercept and an x-intercept. I'll draw these in black. And let's see. X-intercept is located at -1, 0, so that's like over there. And the y-intercept is, I don't know, kind of over here-ish, -4. So first thing we have to do is we have to have a function that connects the dots. And I'll just put my function in magenta here. I know I'm going to have something connecting these dots right here. It has to hit both of those. And then the question is, what does it do at that x-intercept? Does it cross or does it bounce? Well, take a look at the x-intercept again. This is where it came from. That factor right there. Notice that the exponent over that factor is just the number 1, okay? That's odd. And odd behavior means crossing the x-axis, not bouncing. If that had been even, remember if that had been an even exponent, like 2 or 4 or whatever, it would have doinked off like this. But we're not doing that. We're going to cross the x-axis. And because there's no other x-intercepts, right? There's no x-intercept right here. We can't cross it again, so we just go up forever. Okay, and down here, because there's no x-intercept over here, I can't cross it like that. So we're just going to go down forever on this side. So there's the middle portion of our graph. And I find these points are really helpful in dictating the rest of the behavior. Now, as you go over into this section right here, the question is, what's happening there? I have no idea because there's no intercepts to guide me, but I do know something about this asymptote right here. This asymptote, let's see where that comes from. Let me clear some space here. That asymptote is at x equals 2. That comes from this factor right here. And if you notice, that factor is also odd, right? It has an exponent of 1. So when you have an odd vertical asymptote, what that looks like is it comes up from the other side. Notice how I've got this one going down right here. This guy's down. When you have an odd asymptote, that means you come in from the other side. You have to be going up on the other side of the asymptote. Okay, so I'm going to draw these asymptotes that way and for that reason. I've got this guy coming from the upside, and of course I'm going to approach the horizontal asymptote and look like that. Okay, so there's my function in the right interval. On the left, this is also odd, this asymptote right here. If you look at where that's coming from, that's this factor, x plus 3, which has an odd exponent, right? An exponent of 1. That means we're going to come in from the opposite side, like this, and then approach the horizontal asymptote. So there's my entire function for this. And you see the most valuable pieces of information are x-intercepts, y-intercepts. The lack of intercepts told us a lot, right, where you could not cross the graph, and the symmetry of those asymptotes, whether they're even or odd. In this case, everything was odd.